Ways to make AI smarter using cognitive psychology concepts. Cognitive psychology, the study of how people perceive, remember, think, and solve problems, provides the architectural blueprint for moving AI from mere pattern recognition to true reasoning. Here are 30 ways cognitive psychology concepts can be used to make AI smarter. 1. Attention and perception. Selective attention. Just as humans filter out background noise, attention mechanisms, like those in Transformers, allow AI to focus on specific relevant words or pixels, ignoring the noise in massive datasets. Feature integration theory. AI uses layers to detect simple features, lines, colors, and then binds them into complex objects, faces, cars, mimicking how the human visual cortex functions. Top-down processing. AI can use context, like knowing a scene is a kitchen, to better identify ambiguous objects like a toaster, similar to how our expectations influence our perception. Gestalt principles. Computer vision models are trained to recognize wholes, proximity, similarity, continuity, rather than just disconnected pixels. 2. Memory systems. Working memory. Large language models, LLMs, use a context window as a form of working memory to hold immediate information for active processing. Episodic memory. AI agents use experience replay, storing past specific events, to learn from successes and failures over time, rather than just learning from a static dataset. Semantic memory. Knowledge graphs allow AI to store facts. For example, Paris is the capital of France, in a structured way that is independent of specific personal experiences. Consolidation. Some AI systems use sleep cycles or background processing to move important data from temporary buffers to long-term weights, preventing catastrophic forgetting. Retrieval Augmented Generation, RAG. This mimics human cued recall by searching an external database for relevant facts before formulating a response. 3. Learning and knowledge acquisition. Transfer. Learning based on human generalization. This allows an AI trained on one task, like identifying dogs, to apply that knowledge to a new task, like identifying wolves, with very little extra data. Few-shot/zero-shot learning. Mimicking the human ability to learn a concept from a single example rather than needing thousands of repetitions. Scaffolding. AI training often starts with simple tasks and gradually increases in complexity, reflecting the educational psychology concept of building on foundational knowledge. Reinforcement learning, RL, directly based on operant conditioning, reward, and punishment, where AI optimizes its behavior to maximize a reward signal. Social learning. Multi-agent systems learn by observing and imitating the behaviors of other high-performing AI agents. 4. Problem-solving and reasoning. Heuristics. AI uses mental shortcuts, like a star search algorithms, to find good enough solutions quickly when an exhaustive search would take too long. Analogical reasoning. AI is being trained to solve new problems by identifying structural similarities to old problems. For example, this coding bug is like the one I saw in a different language. Inductive reasoning. Systems like GPT-4 perform pattern completion to predict what comes next, mirroring how humans make generalizations from specific observations. Deductive logic. Neurosymbolic AI combines deep learning with formal logic rules to ensure the AI follows strict if-then reasoning paths. Metacognition. Emerging AI systems. Think about their thinking, evaluating the certainty of their own answers, and asking for clarification if they are confused. 5. Language and communication. Pragmatics. AI is moving beyond literal definitions to understand intent, recognizing that "can you pass the salt?" is a request for action, not a yes/no question about physical ability. Schema theory. AI uses internal scripts or frameworks to understand common scenarios. For example, a restaurant script involves ordering, eating, and paying. Universal grammar, modern NLP, is influenced by the idea that there are underlying structural rules common to all human languages, helping AI translate more naturally. 6. Decision-making and bias. Dual process theory. Researchers are building AI that mimics System 1, fast, intuitive, subconscious, and System 2, slow, logical, effortful, to balance speed with accuracy. Bias mitigation. By understanding human cognitive biases, like confirmation bias, developers can program debiasing filters into AI training to ensure more objective outputs. Bounded rationality. AI is designed to make the best possible decision within the constraints of its available computing power and time, a concept pioneered by Herbert Simon. 7. Emotion and social intelligence. Theory of mind. Advancing AI to understand that other people have different beliefs, desires, and knowledge than its own. Effective computing. AI uses sentiment analysis to recognize human emotions via tone and facial expressions, allowing it to respond with appropriate empathy. Cognitive architectures, for example, SOAR or ACT-R. These are blueprints for AI that attempt to model the entire human mind, integrating perception, memory, and action into one system. Intrinsic motivation. Just as humans are driven by curiosity, some AI models are given curiosity rewards for exploring new parts of their environment or data. Mental models. AI creates a simplified simulation of how the world works, for example, physics, social norms, to predict the outcome of its actions before it takes them. Do you know that any private information you put into a cloud AI is used to train that AI? A private AI running on your own hardware is the best way to keep your private data private. I can help you set up a private AI on almost any PC or server. Contact me for a free consultation. If you get value from these blogs, please consider joining my Patreon as a member at the $2, $4, or $8 level. There are more than 400 previous blogs on my Patreon page. https://www.patreon.com/Steve Hovland.